What's up, nerds? Alright, today we are going to do some pretty cool stuff, actually, finally. We're going to integrate and configure the database that we got up and running in Docker last video with our SpringBoot backend. This is the 08 DB integration part B. Part A was already there, I'll link to it. Changed a number of files this time. But before I get to the files, I will run through some notes that I put together. So real quick, the code review objective. So this is what we wanted to achieve in this particular video. We wanted to configure SpringBoot to connect with PostgreSQL DB that we set up. We want to create a users table to store our users, and we want to create an API that will add a new user to the users table that we created. So we're integrating a running DB with our app. So I will copy and paste this command, and let's get it started. So in the repo, we'll go to Spring Backend, bin, Docker, Docker startup scripts, and we will run as a Docker container. So what we're doing is we are using Docker Compose, starting our backend and our database. So we'll run Docker PS, and you can see that the Spring backend is running and Postgres is running. Great. We will log in. So we'll do bin Docker shortcuts, and we'll log in to the DB, and we'll do pSQL app_DB, which is the name of our database. And you can see that there's a users table. We select all from users. There's nothing there, but the app is running. So now we will do our post request. It says it created a new user. Let's go check. Boom, it did create a new user. Cool. So how did we do that? Let's look at the code. The first thing we did was we needed to configure SpringBoot to connect with the PostgreSQL DB, and we had to add some new backend modules. Way back when we started this, this was, like I said, a multi-module backend project. And so we've been working with PJL application, which has our application code, like the main function, the main method that starts our application. But we want to wire in a database. So I created a database module. And this is specific. It will contain everything that we need for the database configuration of the app. So I created this database module just using POM files. And I created database application, PJL application database core. And in here, I have a few things. One is a database local properties file, and the other is a database configuration file. So with Spring, you create these configuration files as you add in complexity. This is actually the first one that we've needed. So you mark it as a configuration file. We're using JPA, and so we enable this JPA repository, and we're looking in base packages. So we're going to name all of our repositories, which is how we query the database from code with com PJL software repository. Transactions management is something that we're doing because every time you hit the API, we're going to be transacting with the database. And we're reading properties from the class path of this module in database profile.properties, default to local. So way back when, we talked about setting the profile. When it's set to local, it's going to load the database local properties file. And this is where we call out what we need to connect, which is the JDBC driver, URL. So we're running it through Docker, so we need to use this injected environment variable, which is the database Docker service name, 5432, and then it connects to the database name, and then we give it a username and password. Now we have set all of these values in the Docker Compose. So these environment variables are being injected to the application So they're available to the backend server when we get started. And these come from the top level env file. So when we start these with scripts, we have all of these Docker variables that we have. So like the default Docker database name is app.db. This is the DataSource username, root. This is our password, quert. We're creating these variables in the env, and when we start Docker with scripts, we're exporting all of these values, we're injecting them into Docker, we're injecting them into the code so that everything is parameterized and we're hard coding as little as possible. So you have a properties file with variables that are coming from the Docker Compose. And like we said, we start this Docker Compose using startup scripts, and those scripts are loading env files and exporting the values that are then injected. And then the database configuration is pulling in and setting the driver, the URL, the username, and the password from that properties file. And we have a bean for the data source that creates a data source for the application. And this is, a SpringBoot configuration file. And once we've done this, we have connected the Spring to the database. And so that is the first kind of bit of code that we'll look at, which was these files, the .env and then the Docker Compose. And that's how you've connected it. So now that it's connected, we want to go to the second part of our objective, which is, all right, well, how does the code create a users table to store our users via, JPA? And so we needed to add in backend modules a user.java file, which is an entity. So this is a new module. It's different. Authentication is its own conceptual idea. It's not part of the core application. The application uses authentication. Authentication doesn't have anything to do with the database configuration. It's completely separate. Therefore, we created an authentication module that has core and models. To create a table, you need to set up an entity. And this is an abstraction and something that's from the Jakarta Persistence API. And so an entity marks this as not just an object, but something that we're also going to make a table. And we've explicitly said that with the table annotation, where this is the name of the table in Postgres. And then we've even said all usernames need to be unique. So this is a way to get the database to enforce things for us. And then we've just picked some high-level things to track. So obviously you need a primary key, which could be the username, but we'll use a generated value, just a string for the first name, a string for the last name, a username. Again, we've marked it as a natural ID, meaning this needs to be unique. You can't have two unique users with the same username, because that's how we're going to log in. But users should be able to update their username in our application. So we put mutable as true, which means you can change this value. They need a password. Things will be stricter as we go forward, but for now we just have to make sure that it's not blank. And then we can mark whether or not the user is enabled. And so I have an empty constructor where I am just setting random values. So random alphabetic values for first name, last name, and username. Password, I'm not encrypting it. It's just a blank. It's just a free text string. We're going to fix this. But I just wanted to, when we create a new user and we save that user, I wanted it to pre-populate unique values for us. And then we just have the getters and setters. So yes, that's how we kind of created the users table. And so once this is there in our local database local properties, we have Spring JPA Hibernate DDL Auto set to update. And this configuration is extremely important because this is what's telling JPA and Hibernate how to take your code and actually apply it to a database. So it has a number of different values that I've outlined: none, validate, update, create, and create drop. In general, I've left some notes. So when you're testing, you would use create drop, which creates the database, then you'd run the tests, and then when the tests are done, you would drop the database completely. In development, which is what we're doing, you would just use update, which keeps the database schema in sync with the latest code. So when you're in the entity, and you're making code changes, you're adding a column, you're adding a new unique constraint, you can have Hibernate look at that and then apply it, recreate maybe, or just apply it to the table that you have in your backend. And then in production, you wouldn't use this at all. It's just too dangerous. Like in production, you need to be much more purposeful about all of the changes you're making in the database. If they're breaking, how are you migrating the user data? Don't use this in production, but for now, we're just going to use update. And then we have this other property for debug, which will print the SQL that's being created from our code and that's being applied to the database. And so that's really, like, now that we've connected to the database in part 1 and we've marked this as an entity, Spring will create this users table for us and apply the constraints. And you can actually see users that we have a primary, it created the primary key and it created a unique constraint on username, and it's set Boolean to not null and user ID to not null, and it has like a next value thing, so it'll automatically increment. You might notice that I didn't have to set anything here for ID, because this generated value in ID knows that it should just auto increment. So if you post again and you do a select from all users, it just goes straight to 2. It knows what to do. And if you deleted one of these, it would still just go to 3. So it's doing that for you, and there are different ways to use primary keys, but this one's fine for what we're doing, and honestly in general. So yeah, that is how we did part 1 and 2. So configure the SpringBoot to connect to our Postgres, created a users table, and now we have to create an API that will add a new user to the users table. We did this in the PJL authentication module. This API, this business function, is directly related to authentication. So obviously we needed a controller, which is going to create our API. So you go to authentication, and we put our controllers in core. So here's our user controller. We've marked it as a REST controller, so Spring knows it's a REST controller. We've created a REST request mapping, just saying this is an API, it's version 1, it's users. And then skipping here, we created a create user function that has a mapping of create. It's a post request, and a pop-up is so annoying. Yeah, it's an application.json. So we're just kind of marking what kind of API it is. Now, how do we get it to, it's wired. We can access it now with a post request. How do we get it to do what we want? Keep in mind this is a partial way of doing it. You should use services. We will get to that later. But for now, we have a user repository. Now, repositories are, not to be confused with suppository. We have created a user repository in the models directory because these are directly related to models. And so once again, we created an interface. It extends the JPA repository, and it returns user entities with primary keys that are long. So this maps to the user we created, and this long maps to the user ID we've created. And it's just an interface. And just doing this wires this up, so it gives us out of the box some pre-configured functions that we will leverage in our controller. So we've auto-wired and dependency injected directly into our controller that user repository. So it knows that it's connected to the users table that we created, and it's going to manage those user entities that we created. Very simply, all we did when you call this post request is save and flush. So you're going to save it and then complete the transaction immediately, which is the flush. You can actually see the user repository comes with a number of different things. Save and flush, some deprecated stuff, save all, get by reference ID, find one, find by ID. I didn't have to write all these. They came with the interface that we extended. But all I want to do is save and flush, and I'm just going to save and flush a new user. Again, it has everything that we need here, and so it's been created. And that's how we created the controller, and we created what the controller does, and it says create a new user. And that's kind of it. You can just keep calling this, and it's just going to keep adding users. In part C of the mini-series, we're actually going to hook this up to Angular, and we'll have Angular add the users for us, and then Angular will view the users. We'll add another controller to actually view the users. But I just wanted to go through kind of the configuration and the setup on the back end before we move to the front end. I actually think this is pretty cool. I hope you enjoyed this. Those are kind of the files, and if you want to know for sure, we'll go quickly through the PR. So in the .env, this is where we have all of our variables that we're injecting across the application. So we have our service names that are saved, and we export those. In the Docker Compose, we've added environment variables, which you see are needed in the Java code in the application in the database properties file. So that's something we talked about. Again, I have 2 Docker Composes, one for the total full stack app and one for just the backend and the database now. So I've updated those all. They're in sync. The POMs were updated, so I added dependencies where I needed them for some of those annotations that I showed you, and I created a mapping between parents and modules. Database configuration file, I showed you all this, we went through that. The database local properties file, we went through that. The pom.xml, again, just setting up the multi-mod project and adding dependencies where needed. Another POM file, a lot of these changes are just POMs. The user controller, we went through this. This is where we created our API and injected our user repository, which we use to save new user objects, objects into our database. Again, the POM XML, which has the imports that we need. I should parameterize this, but I'll actually get rid of this. I'll get rid of that once we move forward and have the user provide the information that we save. This is the user entity, maps to a record in the users table. Showed you everything there. User repository, I showed you everything there. Another POM, showed you everything there. And another POM. So there, I actually went through everything. Few files. Once you know what to do, it's very simple, but also very powerful. Hope this was helpful.